Lecture 3 after a long time, and today's session is all about Young's double slit experiment and all its variations. All of this in this amazing power-packed lecture of Pathfinder series for all the 12th standard and the dropper students with me, Shreyas, your physics master teacher at Vedantu, and I'm going live. Welcome all my lovely warriors, and in today's session we are going to see what exactly is the Young's double slit experiment, the different kinds of variations, lots of problems on it, and that's going to help you in the upcoming JEE 2022 examination. So if you're a 12th standard student, you should definitely watch the Pathfinder series, and in case you have missed the previous classes, I'll tell you where you can watch it. It's right over here. So when you are on our channel, just go to the playlist and just go down out here and you will see Pathfinder 12th standard. So just click on this and you will see right over here, this is the 12th standard playlist for physics. So we can click on this and you will see the entire playlist will pop out right over here. You can click on it and you will see this is the playlist. So the last two lectures, like you can see over here, were on Lightwaves. We have done the Huygens principle right over here. We have done the Huygens principle, and we have also done, there is lecture number 2. I think that's not shown here, but let me add it later on. We have done lecture on interference of light waves as well. All the basics of what is interference of light, amplitude addition, constructive, destructive interference. Don't worry, I'll just do a quick recap. All right, so let's begin. And yep, thank you for smashing the like button as well as hitting the subscribe button out there. Yes, Govindan, we have completed EM waves. Yes, there is only one lecture, but it's a big lecture. Plus, Govindan, EM waves is just a very small chapter. So EM waves is done. Manish, hello. Hi, Lavanya. Hello, Chaitanya Kumar Reddy. Somu, welcome aboard. Yep. So I hope you have also seen the, lecture on EM waves. If you have not seen it yet, please watch it. So we have already started with term 2 portion before the term 1. Okay, so before the term 1 examinations have already started with it. So are you geared up? Let me know by putting up a smiley, putting up a heart, putting up a yo, putting up a thumbs up, and putting up a fire in the chat box right over there. Hello Manish Ilumai. So one interesting and important update, in case you do not know about it, this year Vedantu has created history, never like before. This year more than 1,500 students from Vedantu cleared JEE Advanced. JEE Advanced. JEE Mains, there are many more. Thousands of them have cleared JEE Mains and 1,500 have cleared JEE Advanced. That's almost like 6% of the IITians this year's batch will be from Vedantu. That's a massive growth, and next year you're going to rock it, I'm pretty sure. And yes, if you need help, if you want to cover the syllabus, you want test series, you want assignments, you want more sessions, you want amazing master teachers, that too in English, then you know what to do. And in case you don't, let me tell you, there is a link in the description box for joining the last crash course. This is very important for all of you, for attending all these crash courses along with these discussions out here, so that you get a comprehensive study till the JEE examination end. So make sure you check out the link which is there in the description box, because you get the crash course for just 9,000 rupees with 20 mock tests, with 90 sessions and numerous assignments on all of these chapters. So Ray Optics Ishwar will do it after this. All right, we are going to do it after this. All right, so let's begin. Let's do a quick recap. All right, so let's do a quick recap, my warriors. So we have seen that when light waves or any kind of waves meet, they interfere with each other and they produce a resultant wave. The intensity of the wave is always square proportional to the amplitude. So if amplitude is doubled, intensity becomes 4 times. It's always square proportional. And the resultant intensity is given by this formula, I is equal to I1 plus I2 plus 2 root I1 I2 cos phi, and the resultant amplitude is given by root same vector addition formula, A1 square plus A2 square plus 2A1 A2 cos phi. You can see both the formulas are identical, just that since intensity is square proportional, that's why this formula does not have that root. If you are wondering what is phi, Phi is called, come on, put it up in the chat box. What was phi, my warriors? Do you remember? If two waves are interfering, what's phi? Is it the angle between the waves? No, right? It's the phase difference between the waves. So both the waves may not arrive simultaneously. There might be a lag, there might be a part difference. So that is called as the phase difference. One wavelength carries a phase difference of 2 pi radians. Remember that. Based on that, you have two kinds of special interferences. Remember that. One is called as the constructive interference and the second one is called as the destructive interference. So in constructive, what happens? The crests arrive together, the troughs arrive together, and the amplitude is large, right? Do you remember all of this? And in destructive, the crest and the trough arrive together. So because of which the crest cancels the trough and you see the nullified effect. So in case of, this should not be conservative, this should be constructive. Ignore that. So this should be constructive interference. The phase difference is 0, 2 pi, basically all multiples of 2 pi radians, 2 pi, 4 pi, etc. And the amplitude just adds. Remember, the amplitude just adds and the maximum intensity is given by root I1 plus root I2 whole square. Is that clear? Root I1 plus root I2 whole square. And same thing for destructive interference, it is odd multiples of pi. That means pi, 3 pi, 5 pi, 7 pi. So all the odd multiples of pi, when the phase difference is there, that time you get destructive. So the crest will cancel the trough. Yep. And the resultant is given by A1 minus A2. Okay, amplitude wise, intensity wise, what will happen? This will be root I1 minus root I2. That's the only difference. Root I1 minus root I2. Ray optics, Yuki, like I mentioned, I'll be doing it after completing wave optics. So wave optics, this lecture was remaining, so I have to complete this and then I'll go to ray optics. Don't worry about it. Alright, chalo, let's get moving to the next one. Now, coming up ahead is the main YDSE. That's the short form of Young's double slit experiment. Young is the name of the scientist. Double slit because there are two slits in that experiment, and that's what it's all about. So Neville was asking what's the last point about constructive interference. I'll just mention this over here. See, the thing is, if you have these two waves, let's say the intensity of this wave is I1 and the intensity of other wave is I2. So when they add together and they produce a new wave of new intensity over here, this intensity is given by root I1 plus root I2 whole square. This comes from that formula of I1 plus I2 plus 2 root I1 I2 and cos of 0. Cos 0 is 1. So when you open this bracket, you are going to get exactly the same thing because the phase difference is going to be 0. So that's the short formula for remembering that. Is that okay? Same thing for minimum. You will have a minus because instead of 0, it will be 180 degrees. And cos 180 is minus 1. So that's why you get the minus sign. Is that okay, Neville? Yes, Jude? Alright. Okay. Now, going ahead with the YDSE setup. See, when light travels in the form of waves, okay, the light waves spread everywhere. When it encounters some kind of an obstruction, okay, that is like a slit or some narrow opening, the light spreads. This property of light, of spreading of light, is called as diffraction. What is it called? It is called as diffraction. So what is diffraction? Diffraction is basically spreading of light. So if you have an opening over here and the light rays are coming like this, after passing through that hole, the light will spread everywhere. That is basically the diffraction. So diffraction is nothing but the spread of light. The light spreads, and this is a property of any wave. This is also true for sound. This is also true for light, any kind of wave. Just imagine you're talking in a room. There is a door. The person outside the door or outside the room need not stand exactly in front of the opening of the door. Even if he's somewhere else, the sound spreads. Correct? The sound spreads and the person is able to hear. It's not just because of reflection, it's also because of the diffraction. So that's the property of any kind of wave, which spreads when it passes through any kind of opening and it distributes its energy. Now, this light spreads through this single slit, but remember, to obtain any kind of interference pattern, we need two sources of light. So we are going to make derived sources from a single slit, and this is what we are going to do. We're going to have two slits over here so that we have more spreading of light, and these two slits are going to act like sources of light, but secondary sources. Remember, I have told you about what is called as a primary source and what is a secondary source in Huygens principle. So this exactly is the primary source. You have now got two derived sources from which you got from this particular source, and you know that the light will travel and it will take the same time to reach both these slits, so they both are going to get illuminated. I hope this is clear. Illuminated together, right? They are going to get illuminated together. So that's why they are going to be coherent sources. What are they going to be? They are going to be coherent sources. Is that making sense, my warriors? Is that making sense? Clear? Very good. Now, the thing is, once you understand that these two sources are coherent, it becomes easy for us to predict what's going to happen next. Think about it. What's going to happen next will be very clear once you know if the sources are coherent or non-coherent. Remember, coherent means they are in sync. I know if there is a crest here, there will be a crest there. Or if there is a crest, there will be a trough. There is no ambiguity in that. There is no, mismatch in that. There is always a sync. They are always related to each other. Make sense? So, once we have coherent sources, we are sure of what's the kind of interference pattern that's going to happen, because the sources, the rays, the light waves are always in sync together. And after this double slit, you are going to see both these waves are going to interfere and they will produce a kind of a pattern on the screen. And that's what we are going to study. This is the whole setup. The single slit is there, the source is illuminating it, the double slit acts like the two coherent sources, and the light waves interfere to produce some kind of a pattern on the screen. You're going to study all the characteristics on that. Look at these. Look at these sources. Look at these two sources. This is one source here, this is one source here. Think of it like derived sources from the slit. Think as if this is a slit here, this is a slit here. And from these two slits, you are seeing both the waves coming over here. They are spreading in all the directions. Do you see some places they are producing very good intensity because their crests are arriving together or their troughs are arriving together, like the ones here, the ones here, and the ones here? And do you see a smooth patch over here, and over here? Do you see what it is? Do you see what it is? Okay, think about it. Because once you see that the crests arrive together, they will produce maximum intensity. They will produce constructive interference. So these are those points: constructive, constructive, constructive. But do you see over here in this region and in this region, the crests from here, the trough from here arrive, they nullify, they create a destructive interference pattern over here. So these lines over here are the regions where the crest and the trough arrive together, crest and trough arrive together. So they are creating nullifying effect, which is destructive interference. This is how the pattern looks like for waves. Does it remind you of waves on water? And if it does, you are right. Because this is true not only for light waves, but also for sound waves, but also for water waves. It's true for everything, my warriors. So these waves which are produced from both these slits, the waves which are produced from both these secondary, derived, coherent sources, as they proceed ahead, you will see they will produce interference, and on these red lines there will be constructive interference. They produce constructive interference, and in between that, these pink dotted lines, they produce destructive interference. So I'll repeat, on these red lines, they produce constructive interference, and on these pink lines, they produce destructive. Why constructive, why destructive? We'll look at it geometrically in a bit. For now, understand, just by the simulation, you have just seen how it produces constructive and destructive interference. Wherever there is constructive, that means the light intensity is more. Wherever there is destructive, that means the light intensity is low or it's dark. So that's the reason why if you hold a screen in front of this kind of a setup, what are you going to see? You're going to see bright spots or bright regions, and then you're going to see dark regions somewhere. Bright regions, dark regions. Bright regions, dark regions. Correct. Dark is destructive, bright is constructive. So exactly that's what is going to happen, and you're going to see constructive destructive pattern. This is called as a fringe pattern. These are called as the fringes. This is one fringe, dark fringe, bright fringe, dark fringe, bright fringe. So you're going to see fringe pattern on the screen. Is that clear? So what have we learned till now? The moment you have double slit, it acts like a derived coherent source, and they produce interference on the screen. Some places light waves meet constructively. That's where you get the bright fringes, the bright region, and where they cancel out each other, there you will get the dark fringe. Perfecto. Now let's look at these simulations once more so that you get the perfect understanding. So again, the same thing, you can see that those two sources interfering. Look at these regions, they are cancelling out. This region cancelling out, this region cancelling out, this region cancelling out, bright, 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 and dark, dark, dark. So you can see on the screen, alternate bright and dark fringes are there. You can see that beautiful simulation out here. Alternate brights and darks. That's what it is all about. Now this is also true for water waves, and there is a beautiful channel called as Vedantu, and you know, this kind of setup was also done on water waves. So by taking two bobs and making them oscillate together to simulate the effect of light. So the light waves were simulated on the water surface on a still lake, and the interference pattern was also found on water. That is amazing. Yes, Muthuram, I'm taking pro subscription classes. Hi, Arnav. All right. So this is beautiful. So this is again another simulation to make you visualize how things are going on. The water waves act exactly like light. So the moment they pass through those slits, or you have two sources of bobs which are going up and down in water, they will create ripples of water, and they will create exactly the same kind of interference pattern that one would expect for light. But yes, you don't get bright and dark fringes. You will just have the waves going up and down more in the bright parts, and in the dark parts the waves won't be going up and down so much because of the destructive nature. So here's a question for all of you. If you use a torch in place of the light in Young's double slit experiment, what do you think will happen? What do you think will happen? So instead of a slit, imagine you use torches, torch 1, torch 2, and then you put up a screen. What do you think are you going to see on the screen? Will there be a fringe pattern appearing for a moment and then it will disappear? Will the fringe pattern occur as normally from a monochromatic light? Monochromatic means mono is single, chroma is color, single color light, okay? Or only bright fringes will appear, or no fringes will appear. What do you think? Okay, Arnav, yes, the sprint class will start at around 7 o'clock. Yep. Dinesh, if you have not completed waves chapter, then probably Dinesh, it is going to be little difficult. So I would advise you to watch my first 2 classes of waves and then watch this lecture. That will be better. If you have not studied waves at all in 11th, but you have studied waves in 11th and you remember a bit of it, then yes, this lecture will make sense for you. Amjad, I'm very good bacha. So hence, think about what the answer to this question should be. If you use a torch in place of monochromatic light, what do you think you will get? Well, what is the whole point of having this double slit? Why are we using double slit? Why can't we just have 2 sources of light? Why? The word fringe, fringe means a band, bright band. Band is called as a fringe. Okay, so fringe is like a band. It's like a band of color or band of some dark thing over there. So bright fringe, dark fringe. So layers, or you can say bands of bright and dark pattern over there. So that's called as a fringe. So think about this. What will happen if I use a torch here and if I use another torch here? Don't you think I should still see the interference pattern? The answer is theoretically yes, but practically no. Because what's the guarantee that when this torch will be emitting light wave, this torch will also emit light wave? Although you might be like, sir, obviously both the torches are on, so both are emitting light waves. The correct answer is no. In minute scales, at the exact same instant, you might not have the same light wave coming from both the torches. Even if it is from the same manufacturer, even if it is identical torch, you will never get the same kind of wavelengths. Maybe from torch 1 you are getting this. At the same instant you are getting this from torch 2. Maybe at next instant you are getting this in a broken format from torch 1. Broken means sometimes the wavelength is there, sometimes it's not there. Again a wavelet is emitted. So wavelets could be emitted. It might not be continuous. So maybe at that same time from torch 2 you are getting this kind of a wave. So sometimes there are waves, sometimes there are no waves, sometimes there is a crest, sometimes there is a trough. So there is no sync together. There is no sync. If there is no sync, obviously sometimes you might get constructive, sometimes you might get destructive. It's completely random. So you will not get a complete interference pattern over here. It will be a complete randomness over here. That means it's just going to be illuminated because it's going to average out at the end of the day. So what should be the correct answer, my warriors, for this question? No fringes will appear. Welcome back, Vikram. I'm so glad you're back. The frequency may vary. Yes, the frequency may vary if the torches are not identical, and also if the torches are not emitting pure one color. So maybe if it's a yellow color torch or a white color torch, it has a mixture of colors. 2-3 impure colors are there. So that is also possible. So that's why for YDSE you use a single color source, number one, and you derive two sources from it rather than having two independent, asynchronous, incoherent sources which do not produce interference pattern. Yep. I hope this is clear. Dinesh, only ray optics is the major chapter. Other chapters like modern physics, I'll tell you how to do it. Don't worry. Major chapter left is ray optics and modern physics. Modern physics is easy one. Okay, don't worry about it. The main thing that we need to focus on is ray optics after this. All right. Okay, so let's get going. Yes, Sonam Pandey, that's the correct answer. Now let's look at how these dark and bright fringes are formed and what are the conditions and the formulas associated with it. All right. So here is what we are going to do. First of all, I want you to visualize this. These are the two slits. Okay. This is our screen over here. I have drawn the perpendicular bisector over here. Okay. This is a perpendicular bisector. This is the midpoint on the screen. This small d is the distance between the slits. Okay. So I'll mention what these things are right over here. So the small d is basically distance between the slits. Then you have capital D, which is the distance from the slits to the screen. You can see the capital D distance is slits to the screen, that's the distance, and this is generally much larger than small d because the slits are very close. This distance is very large, something like this. These two slits could be here and maybe the screen might be here. So these two are very close, they are very narrow, close to each other. That's one thing which you should know. Okay, next thing, from the midpoint, wherever you want to calculate, wherever you want to analyze what kind of interference is happening, that's the point P on the screen. So this is some point. That point P subtends angle theta with the perpendicular bisector. So everything is measured with respect to the perpendicular bisector. This is generally associated with origin. So that angle theta is also called as the angular position. Angular position position of point P which needs to be analyzed. So you're basically analyzing it. You're basically analyzing that particular point, which kind of interference is happening over there. Fair enough. This much is clear, I guess. Very good. Perfecto. Now, what kind of interference is happening over there? To understand that, the only thing we need to know is what is the path difference. Recollect that. If you have two waves, okay, one wave is reaching earlier, one wave is reaching later on. So the lag between them is basically called as the path difference. Do you remember that? So that path difference tells you whether it is constructive or whether it is destructive interference. I hope you remember this. So let's try and do this now. What kind of path difference is that? Perfect. So if you notice, till here the waves reach simultaneously. Till here the waves reach simultaneously. The path difference is occurring because the wave from this slit has to travel shorter distance. The wave from this slit has to travel more distance. Just imagine if there is a Pandu over here and if there is a Champa over here. Okay, if there is a Pandu and there is a Champa over here, and if both can travel at the same speed, and both of them are asked to start from here and reach here, who will reach first? Who will reach first? Obviously Pandu will reach first because Pandu has to travel lesser distance. And by the time Pandu reaches here, Champa will be here. So do you see this is the path difference? This is the path difference. So basically there is going to be some path difference because the waves are having a bias in the terms of distance. One has to travel less, one has to travel more. So the path difference delta x. So this is the path difference. Okay, so that path difference can be easily calculated. So that delta x will be, look at this, this is S2P, the longer distance, minus the shorter distance, which is S1P. Now, because this distance is small, if I make a suitable assumption, like pivot your arm or pivot your compass at point P, take the radius, like everybody knows how to draw an arc using a compass, right? You have drawn it, right? You have drawn it using your geometry set box. You pivot it over here and then make sure that the radius is exactly this much. Make sure the radius is exactly P to S1 and then draw an arc. Just draw an arc. So now you will see that this is the extra distance you have to travel. Do you see that? This is the extra distance you have to travel. Do you see that, my warriors? So if you draw an arc, keeping the center as point P, you will immediately realize that this is the extra distance you have to travel, and if I mark this point as Q, this is exactly the difference between S2P and S1P. So hence, exactly this is going to be approximately, S2Q. Why is it approximate and why is it not exact? The reason for that is because I have drawn an arc. Understand, when I draw a straight line and that arc, there will be a small difference. So when I draw an arc like this, maybe it hits over here. But when I draw perpendicular, it's a straight line. So there will be a small difference between those 2 points. But since S1 and S2 are very close, the difference between the straight line and the curved line will be very small, negligible. So I can ignore that. You can ignore that. Hurry and you will find it in the playlist, bacha. There is a playlist tab on YouTube only on this channel. You will find it there. So that's the reason why I'm putting it as approximate. Okay, that's why I'm putting it as approximate S2Q. Now what is S2Q? Think about it in this triangle. This triangle, if this is theta, think about it, if this is theta, okay, then I believe that even this angle should be theta. Parallel lines almost. If this is theta, even this is theta. And if this is theta, this is 90 minus theta. And if this is 90 minus theta, even this should be theta, right? Think about it. Even this angle should be theta, right? Because this is theta, this is 90 minus theta. And in this right angle triangle, these two will be complementary to each other. That's it. So now you can see S2Q is opposite to theta and S1, S2 is the hypotenuse. So I believe it will be nothing but S1, S2 into sine theta. What is the value of S1, S2? S1, S2 is the distance between the slits. So it will be d sine theta. So delta x is d sine theta is what we have got. Most important result till now. Pathfinder, hurry on and just search for Pathfinder Physics, you will get it. Okay, Pathfinder Physics. I have just shown it to you at the start of the lecture. If you can scroll back towards somewhere at the start, beginning, I have showed how to exactly find that playlist at the start itself. Don't worry, you can find it over there. Okay. Now that we know that the path difference is d sine theta, memorize this. Let's make use of this now. So now that we know delta x is d sine of theta, delta x is d sine of theta, the next set of approximation that I can do is think these angles over here are generally small because your slits will be here. This is your screen. Here you will get your bright fringe, dark fringe, bright fringe, dark fringe, bright fringe. You will get so many fringes over here. The angles that these are going to subtend, these angles, the angles are generally small. The angles are generally small. That region of interest is small. So the angles are small. And when angles are small, what happens? Sine theta approximately becomes tan theta. Do you remember this? This is a trigonometric substitution approximation. Tan theta, sine theta, theta, all of them become equal. And if that is the case, think about it. What is tan of theta? Opposite by adjacent in this big triangle. So you will see this will then become dy by d. So delta x can be written down as small d sine theta. It can be also written down as dy by d. Both of these are equivalent of each other. Perfect. Hi Dakshin. Welcome aboard. Now that you have got it till here, the only thing left is the condition for bright and dark. What is the meaning of bright? Bright means constructive. What is the meaning of dark? Dark means destructive interference. So it's now obvious. So what do you do for destructive interference? For destructive interference, this path difference should be how much? This path difference should be always odd times lambda by 2. 1 lambda by 2, 3 lambda by 2, 5 lambda by 2, 7 lambda by 2. I have given this to you in my previous revision class for waves. Just watch it in case you have missed that lecture number 2 of light waves. So basically you will get dy by d is equal to odd times lambda by 2. And the same thing for constructive. For constructive interference, what are you going to get, my warriors? Dy by d will be just any integral multiples of lambda. 1 lambda, 2 lambda, 3 lambda, all these things will do. Yep. So if d is not very large than d, then the only option left now is to use Pythagoras. There is no other way then, okay? So that makes it very complicated. There are questions like that. We are going to do it for advanced class. Don't worry about it. So you are going to make use of Pythagoras theorem. You're going to make this as the hypotenuse of triangles and then solve it via some approximations if needed. Hi Ashwarya, welcome aboard. Good evening. Hi Abdul, welcome aboard. So this is the condition. Now from this you can find the y coordinate. So the y coordinate of the bright fringe. The y coordinate of the bright fringe will be n times lambda d by small d. N times lambda d by small d. And the y coordinate for the dark fringe will be odd times lambda capital D by 2 small d. Both of them are different, and that's the reason why you get alternate bright and dark. Bright and dark. You can see that. When n changes from 1, 2, 3, 4, you will get bright points at y is equal to lambda d by d, 2 lambda d by d, 3 lambda d by t, and so on and so forth. Same thing over here. Destructive will get it for odd numbers are 1, 3, 5, etc. 1 by 2 is 0.5, 3 by 2 is 1.5. So you are going to get 0.5 over here, 1.5, 2.5. You can see these numbers are exactly in between 1, 2, 3, 4. So they are exactly, in between them. So that's why you get alternate bright, dark fringes. Is that now obvious? Is that now clear? Is that now understood? Please let me know if you guys have got it. Two important formulas, part difference. Next, part difference is equal to n lambda or odd lambda by 2. That's by basic theory of constructive and destructive interference. That's all you need to remember. Fair enough. Now, let's talk about something called as the fringe width. And then we'll start with the problems. What's the fringe width? Fringe width means what is the distance from one bright region to the next bright, or from one dark to the next dark. Both of them are called as the fringe widths. Okay, whether you measure it from bright to bright or dark to dark, it's the same thing. And it is very obvious how you can find the fringe width. Think about it. Let's say you know the location of any bright fringe over here, Bn, and that location is Yn. The next bright fringe, which will be Bn plus 1, will be at a distance Yn plus 1. What is Yn plus 1? N is that order, that number which you substitute in that formula for y. Remember that Yn formula, I just got it as n times lambda d by d. So the next bright fringe will be at the next number after n. What is the next number after n? N plus 1. So the distance between them is the fringe width beta. That's the symbol between them. Fringe width is expressed by the symbol beta, is the difference of the next fringe to the previous fringe, whatever that distance is. So what is Yn plus 1 going to be? What is Yn plus 1 going to be? Yn plus 1 will be obviously n plus 1 times lambda d by d. So think, what will be the value of beta? Value of beta will be n plus 1 times lambda d by d minus n times of lambda d by d. You can see n, lambda d, dd will get cancelled. Only one term will remain, and that is lambda capital D by small d. So that's the value of fringe width. The value of fringe width depends on the wavelength, on the distance, and the distance between the slits. So basically, what has happened, you can see over here, if you somehow narrow the distance between the slits, if D decreases, you will see as the denominator decreases, fringe width will increase. So if you decrease this, this is going to increase. If you use wavelength of higher magnitude, then also the fringe width will increase. And if D increases, that means you keep it really far away. You keep this screen far away, then also the fringe pattern will increase. That's what is happening. Okay, so remember this formula. Fringe width is lambda d by d, is the distance between any two bright or dark fringes. As simple as that. Okay. Now, the position of dark fringes, Sonam, I just gave it to you in the previous slide. Remember, I gave you a lambda d by d and odd lambda d by d, 2d, those formulas. Those are the positions of alternate bright and the dark fringes. Okay, so that's what you need to remember. So in case you have forgotten that, remember this again. So y for bright is n times lambda d by d, and y for dark will be odd times by 2 lambda d by 2d. Even if you calculate by subtracting the dark fringes, you will still get the same answer. It's not like you're going to get different. You can try it out at home. It's not that difficult. Okay, so even if you subtract 2 dark fringes, you are still going to get it as lambda d by d. It doesn't make any difference. That proves that the bright fringes are equally spaced between the dark fringes and vice versa. Bright and dark fringes are equally spaced between each other. All right. Here is the question coming up on your screen. The monochromatic green light of wavelength this much illuminates a pair of slits which is 1 millimeter apart. The separation of adjacent bright and dark lines on that pattern formed on the screen, which is 2 meters away, is given by. Okay, yes, I'm coming to part difference which is introduced due to glass slab. And by the way, Aram, in the last class, lecture number 2 of Lightwaves, I have already given the formula. What is the part difference when you introduce a glass slab? Make sure you check that video out. Yes, please check that video out. Part difference due to glass slab was discussed in lecture number 2, where I have discussed general interference of waves. So make sure you check that out. All right, so let's try and solve this question. What and all do we know out here? We know the wavelength of light, which is 5 into 10 to the power minus 7 meters. We know the slit distance, which is 1 millimeter. So 1 millimeter is 10 to the power minus 3 meters. And the distance from the screen and the slits, capital D, is 2 meters. And you can see it is much, much larger than small d. So all our approximations are valid. The question says, what is the separation of adjacent bright and the dark lines? Let's try and understand this. Okay, so here it is. First, if this is a bright region and this is a bright region, the difference, this is bright, okay, this is also bright. The difference between the two is the fringe width. The dark fringes will be here, right? These are the dark fringes. Now, what does the question ask you to find? Separation between adjacent bright and dark lines. Adjacent bright and dark lines. That means the question is asking us to find what is this distance. What do you think is this distance? Is it beta, the fringe width? Think again. From bright to bright it is beta. Dark to dark is beta. And bright and dark are symmetrically placed, equidistant. So actually speaking, what is the distance? The distance which you have to find is nothing but beta by 2. That's what you need to find. Correct? Very good. Oh, I'm so thankful and really happy, Vignesh. Hope to see all of your classmates and your friends on this channel. Thank you. You're a true warrior. So beta by 2. What is beta by 2? Beta by 2 is nothing but 1 by 2. Formula for beta is lambda d by small d. So half into, just substitute the values, 5 into 10 to the power minus 7. Distance is 10 to the power minus 3 divided by small d. Small d is nothing but 2 millimeters. I hope that, oh sorry, lambda capital D, my bad, sorry guys. Lambda capital D is nothing but 2 divided by small d. Small d is 10 to the power minus 3. So you can see this 2 and this 2 gets cancelled. So you are just left with 5 into 7 and 3, only 4 will be left. So 10 to the power minus 4, correct? So now 5 into 10 to the power minus 4, but this is meters. You can also write it as 0.5 into 10 to the power minus 3 meters, which is 0.5. 10 to the power minus 3 is millimeter. So 0.5 millimeters, that should be the answer. Many people end up writing this as 1 millimeter. Yep, very good Arnav, very good Sonam. Excellent. Moving ahead to the next question coming up on your screen. Now, in Young's double slit experiment, how many maximas can be obtained on a screen, including the central maxima? Yeah, so, oops, yeah, okay, anyways, this was the previous thing. Yeah, so including the central maximum, the wavelength is 2000, the distance between the slits is 7000. These kind of questions are very common. Okay, so let's see how to do this. Hello, good evening, Sasasmita. Suhita, it is standard like the previous sessions only. Whatever the earlier timings of sprint sessions were, it's almost going to be the same time, plus or minus 15 minutes. Now, in order to solve these kind of questions, I'll tell you what to do. There is a small trick, and listen to the trick. Just first of all, visualize the diagram. This is basically the distance between the slits. Okay, this is D, and this is my screen. This is my central line. This is the central maxima. Why am I calling it central maxima? The reason why I call it central maxima is because both the waves, when they originate from here, they take the same time to reach O. And because they take the same time to reach O, what do you think is the path difference between them? Because they reach at the same time, there is no lag, right? So the path difference over here is 0. They reach simultaneously. And if it is 0, both crests come at the same time, it creates a maxima. So central maxima. I hope that makes sense. Now, as you go little bit far, let's say you go over here, you can see, you can see that this ray has to travel more distance than the other ray. That means the path difference is increasing. You can see that this ray has to travel little bit more distance than the other ray. So the path difference is increasing. So as and when you turn it towards there, you will see the gap increases. The other ray has to travel more distance to catch up with the other ray. Eventually, when you reach at infinity, that is when the rays go like this almost. So at infinity, okay, think how much extra distance does the other ray have to travel as compared to the other ray? Think about it. No, Sasasmita, this is a little bit higher than volts. So this is for JEE Mains and Advanced. Okay, so think about it from this point and this point. If you compare, when the rays reach at infinity, well, a very, very far distance, almost parallel. Think about it. When they meet finally over here, the other ray has traveled an extra distance of d, small d. Do you see that? Do you guys see that? That small d is that extra distance. So when you are at infinity, can I say delta x comes tending towards small d? Agreed till this point? Everybody agreed till this point? Cool. Now that is the catch for the or that is the trick which you need to remember for solving these kind of questions where you have to find number of maximas and minimas. Observe how. See, first of all, d by lambda is the value which you need to find, which is 7000 divided by 2000, 0 goes. So d will be equal to 7 by 2 is nothing but 3.5 times of lambda. D is 3.5 lambda. Now what it means is that if you have these two sources, this is the central line, this is the screen. Here delta x will be 0 lambda. As you go up, the value of delta x will keep on increasing. Somewhere or the other, delta x will be 1 lambda. As you reach somewhere here, as you reach here, somewhere or the other, it will be 1 lambda. What is the value of d? 3.5 lambda. 3.5 lambda. So as you go up, somewhere else you are going to get delta x is equal to 2 lambda. Remember, the path difference is increasing. But what is the max value till which it can increase? It is d itself. So as you keep moving up, somewhere else you are going to get 3 lambda. But will you ever get 4 lambda? Think about it. Will you ever get 4 lambda? Because d itself is 3.5 lambda. So you can never ever get 4 lambda. It's not allowed. Because the max value of delta x is d. Is that understood, my warriors? Can you understand this? So here the path difference is 0. Somewhere it is 1 lambda, 2 lambda, 3 lambda. The max is 3.5. You can't go above 3.5 because I just calculated this. So hence 4 lambda is out of question. So the same thing should also happen below, right? So you should have 1 lambda, 2 lambda and 3 lambda below. So how many fringes are there? Can you count it? These are all bright because all integral multiples of wavelength is bright fringes. So 0 lambda, 1 lambda, 2 lambda, 3 lambda, 1 lambda, 2 lambda, 3 lambda, 6 plus 1, 7. 7 bright fringes will be there. 7 bright fringes. So hence the answer will be 7. If the question said what are the number of dark fringes? What are the number of dark fringes? Here there was about bright fringes. What if the minimas, maximas means bright, minimas means dark? That's obvious. So if the dark fringes were asked, then what will you do? Think again. If dark fringes were asked, again think about the same kind of situation. Somewhere it will be 0 lambda. Okay, for dark, what will happen? You should not think about 1 lambda, 2 lambda. You should think about 0.5, 1.5 because it is always odd number by 2. Odd number by 2 is 1 by 2, 3 by 2, 5 by 2, which is 0.5, 1.5, 3.5 and so on and so forth. So then you will get somewhere or the other 0.5 lambda. This will be your first dark fringe. Then somewhere or the other you will get 1.5 lambda. That is your next dark fringe. Somewhere or the other you will get 2.5 lambda. Same thing over here. You will get 0.5 lambda. You will get 1.5 lambda. You will also get 2.5 lambda. You will also get 3.5 lambda. Is it? Should you take into account 3.5 lambda? Yes or no? Because the highest value is 3.5 lambda. What do you guys suggest? Should we take 3.5 lambda? Yes or no? Think about it. Think about it. Should you take 3.5 lambda? Yes or no? Think about it. Should you take it or not? Obviously, if you go by mathematics, you will realize that this is tending towards. And the meaning of tending is that it never becomes equal to. So the value of delta x, the part difference, never actually becomes 3.5. It comes close to it. It might become 3.49, 3.48, but it will never actually become 3.5, which is 7 by 2. It will never become. So these values should not be taken into consideration. So that's it. So 1, 2, 3, 4, 5, 6. 0 is a maxima. Don't take that into account. 1, 2, 3, 4, 5, 6. So 6 dark fringes. That's how you need to do this. That's the trick. Got it, my warriors? So what has happened? Whenever you have to count the number of bright and the dark fringes, always remember that on the screen mark the central maxima. This is the central maxima, and then you will get 1 lambda, 2 lambda, 3 lambda. These are all your bright fringes or bright spots or maximas. And correspondingly you will get points where there will be 0.5 lambda, 1.5 lambda, 2.5 lambda, etc. These will be your dark fringes or your minimas. Count how many such things can be there, because the max value, remember this, max value of delta x is always tending towards small d. So it can only go till small d, nothing else, nothing more than that. That's the trick you need to remember. Fair enough. Let's move ahead. Let's talk about angular fringe. Now, what is angular fringe width? See, just like you have fringe width, angular fringe width is how much angle does the fringe subtend at the center of the slit. That's simply put the angular fringe width. Yep. So let's try and figure out the formula for this. The angular fringe width is basically the angle subtended by a fringe. Is called as the angular fringe width. Now we all know that the fringe width is generally very small, in micromillimeters, this small. So something like this. This will be your fringe width, and that's it. This is your fringe width, and this is the angle which is subtended. Can you see this is like an radius, this is like a sector, this is like an arc, this is like an arc, this is like a radius, and this is nothing but the angle over there. And you know what is the length of the arc? The length of the arc is r theta, right? So just make use of that fact. Length of an arc is radius multiplied by that angle which is subtended. So just think of it the same way, you are going to get the answer. Length of the arc is beta, radius is the distance approximately, so it is d into that alpha is that angle, so alpha will be beta by d. So that is your answer. You don't have to remember it separately, but yes, if you remember it, it's very easy, else you will waste 1 or 2 minutes just deriving that. So alpha, which is the angular fringe width, is beta divided by d. Better thing to remember is beta is angle into radius. R theta is the length of the arc, radius is the distance between the slits and the screen. Isn't that easier? Yep, I hope that makes sense. Perfecto. Let's talk about a problem based on this particular concept. Here we have a question. Yes, you will get it as lambda by d sonum if you substitute the value of beta, because beta is lambda d by d. So if you substitute the value of beta, you're going to get this. That's like obvious. Okay. Now in the double slit experiment, the angular width of the fringe point is 2 degrees for sodium light of these many Armstrong. In order to change the width of the fringes by 1%, what do you think you need to do in the wavelength? If you want to change the angular width of the fringes by 1%, so what do you think you need to do? Mr. Econut, this is an English channel, bacha. We have a English or a Hindi channel as well on Vedantu. So this channel is meant only for English medium students, or if you understand English. But if you don't understand English or you want to learn in Hindi, then yes, we have a Vedantu Hindi English channel as well. All right. So yeah. Cool. So let's get going. How do you solve this problem? The question is on angular width, right? Angular width. So angular width is nothing but, I just told you, it is beta divided by d, and beta was lambda capital D by small d, and this d comes from here. This d and this d cancels, so it will just become lambda by d. Now, if the question says you want to increase the width, angular width by 1%, so if you want to increase this by 1%, so on this side the numerator should also increase by 1%. So if this increases by 1%, then this also increases by 1%. So what is 1% of the wavelength? 1% of, what is that? 5890 Armstrong will be 58.9 Armstrong. So you have to increase it by 58.9 Armstrong. As simple as that. Okay. I'm so glad, Sonam, you're able to understand, and I'm pretty sure you should definitely prefer learning in English over Hindi if you are especially an English medium student, my warriors. Because at the end of the day, there is a reason why your parents or you have taken admission in English medium school or college, because you want to learn everything in English, you want to understand in English, only then you can talk and properly converse in English when you graduate, and this helps you in long term in your life, because then you might miss out on certain opportunities just because of that language barrier, and you will eventually realize it's not just about physics, chemistry, maths that you learn in life, but it's also about communication skills as well. So it's better that you start preparing yourself for communicating with others, or in general socializing with each other in English, because at the end of the day, I'm pretty sure you want to go to different countries, you want to learn different cultures, and you want to obviously mingle with each other, and that can better happen with English only. I hope that is clear. Alright, option A is correct, and let's move ahead to the next question. Okay, so now we'll come to the different concept, which is YDSE in a different medium. Then we'll have glass slabs and other variations as well. What will happen if somebody becomes very angry, furious, and immerses this entire Young's double slit experiment? This is S1, this is S2, this is my screen, correct? This is my screen, this was my source. Somebody dips this in a medium, in a refractive index mu. So if you dip this entire thing, what do you think is going to happen? The refractive index is mu. Think about it. Okay, so here is the thing. If you change the medium, the first thing that's going to change is the wavelength. Because that's what happens when you change the medium. The speed of light will change, and C is F times of lambda. Frequency is going to be the same, but the speed of light will now become C by mu. It will decrease. So will the wavelength. It will become lambda by mu. And if the wavelength decreases by a factor of mu, that means, understand, the fringe width will change. So beta will become lambda by mu d by small d. So essentially what has happened, this number has come mu in the denominator. So it will decrease. So the fringe width will decrease. The entire pattern will collapse. If you had fringes over here like this before, if you had the fringes like this over here before, this was your central maxima. After dipping it in the medium, all these fringes will come closer. They will come closer. Okay, so they will collapse. The fringe width decreases. That's what is going to happen by this factor of 1 by mu. I hope this is clear. Yep. Shall we go ahead? Rajna, well, I have not yet started ray optics, but I have completed telescope microscope last year. If you want to watch it urgently, definitely you can watch it from the last year's lectures. But this year, yes, I'll be doing it after this chapter only. Okay, so Arnav, I need to consider that there are all kinds of students. I'm so proud that you are able to understand it really fast. And you know, there are a lot of students who need that slow explanation, not exactly slow, but the average explanation. So for them, I need to make sure that my pace matches with every student. I need to be in resonance with every student, all right? So let's get going with the next question coming up on your screen. In Young's double slit experiment, the y coordinate of the central maxima, many students are going to make a mistake. I can visualize this. Central maxima is 2 centimeter and 10th maxima is 5 centimeter. So 0, 1, 2, 3, 4. So 0th maxima is at a 2 centimeter. That means origin is different. And the 10th maxima is at 5 centimeter. The question is basically what will happen if you immerse this setup in a liquid of refractive index 1.5. Shri, which term are you in? Which standard are you in, Bacha? Tell me which term does Lightwaves belong to? Shri, which portion is this? Is this term 1 or is this term 2? Is this 11th standard or something else? I think you have not yet opened the NCERT book, Shri. Maybe you should, it's a good time you open up what's there in NCERT and have a look at what's there and what's not there. Okay, in term 2. Alright, so let's see how to solve this question. Yes, bacha, this is 12th term 2 only. Okay, chalo, let's get moving. First of all, let me draw the y-axis. This is the y-axis. This is my origin. Where is the central maxima? The central maxima is at 2 centimeter. So, at this point, you are getting the central maxima. Central maxima basically at 2 centimeter. Now, the 10th maxima is at 5 centimeter. 10th maxima is somewhere over here. So 10th maxima is at 5 centimeter. 10th maxima means how many fringes are there between this point and this point? So between this and this, how many fringes are there? Obviously 10 fringes are there. Correct? 10 fringes are there. Now the moment you immerse it in a liquid, these fringes will collapse. These fringe widths will decrease, right? And you will see the entire pattern will shrink. But the central maxima will remain wherever it is. The central maxima will remain wherever it is. It will not change. The one on the top will come closer. The one below will also come closer. So central maxima does not change. So even after dipping it in a liquid, so afterwards, the central maxima remains as it is. So the y coordinate of the central maxima should be still 2 centimeters. This option says 3, which is wrong. This says 4 by 3. This is also wrong. So it will be either A or C. It will be either A or C. Now you can logically think, because the pattern shrinks, obviously this maxima should come closer. So obviously the answer should be less than 5. So obviously 7.5 can't be the answer. 7.5 can't be the answer. It has to be 4. So via elimination you can directly get it. But if you want to calculate it, still let me show that to you. 10 fringes. What is the width of this? The width of this is 5 centimeter minus 2. So 5 minus 2, which is basically 3 centimeters is the width of this. So when you dip it, what is going to happen? This width, the width between the 10 fringes, the width between the 10 fringes will be 3 divided by mu. It will reduce mu times because wavelength goes down mu times. And what is mu? Mu is 1.5. So basically it is going to become 2 centimeters. It's going to become 2 centimeters. So the new width is going to become 2. So you are going to get the new 10th maxima, okay, at a distance of 2 centimeters from here. But from the origin, it will be 2 plus 2. That's why the answer is 4 centimeter. This 2 plus this 2 will be 4. Okay. I hope that is clear. Very good, Vasik. Very good, Sonam. Very good, Arnav. Excellent, my warriors. Moving ahead to the next question coming up on your screen. If yellow light in the YDSE experiment is replaced by red light, what do you think will happen to the fringe width? Now this one is an easy one. It's a build up to the next concept. What do you think will happen in a YDSE setup if you use, a different color light instead of, the usual red light? Usual yellow light. If you replace yellow light with red light, think, how is fringe width related to wavelength? Beta is lambda d by d. So it's proportional to the wavelength. So who has larger wavelength? Yellow or red? If you know that, you have got the answer. Who has more wavelength? Obviously red. It starts with violet. Violet has the least. Then you slowly go to blue. So Vibgyor. So violet, indigo, blue, green, yellow, orange, red. So yellow is lesser than red. Hence the answer is increases. You can see yellow has less wavelength. Red has big wavelength. So fringe width increases. And that's the reason for this. Perfecto. It's C. Perfecto. Moving ahead to the next question. Now this is very interesting. If you use white light as a source and you split it using the double slit and then you see what is formed on the interference on the screen, then what do you think you will get on the screen? You will see a large number of colored fringes, I guess. What do you think you will get? I'll give you a hint to think about it. Okay, here is what I want you to think about. Imagine if this is white colored light source and these are your two slits. The white color, okay, the white color light will go here as well as here. What is white? White is the combination of all the colors: violet, indigo, blue, green, yellow, orange, red. Instead of thinking about white as a color, think of it like individual colors. Think it's made of blue color as well as red, as well as yellow, as well as green. Every color is there in it. So if this is your screen, think what will happen if there was a blue color light coming. How will the pattern be formed at different places? Then think what will happen if red color light will come. Think what will happen if green color light will come. What will be the difference in it? Guys, you will understand that red has the highest wavelength. Red has the highest wavelength. Violet has the lowest wavelength. So if you think as the combination of all the colors, then you will start making sense out of this particular scenario. On the screen, okay, on the screen, at the center, all the colors will appear together. All the colors will meet together. That means they will form constructive interference. Out of all the colors, who has the largest wavelength? Red. So red color will have the biggest fringe. The biggest fringe, the biggest bright fringe will be for red. Okay, biggest red fringe, biggest fringe will be for red color. Green is somewhere in between, so green will be probably somewhere like this. Just think about it. The green fringe width will be slightly in between, and the blue will be, or violet will be the least. So violet will be the narrowest fringe. So now think, in this region all the colors are meeting. So if in this region all colors are there, what are you going to get? White in this part. You are going to get white in this part. Everybody agrees to this. And towards the end you will have reddish color. You will have reddish, and slowly again after this you are going to see, yes, this blue fringe will again repeat itself somewhere here maybe. It will repeat itself somewhere here and also over here. But the red fringe will take a long time to repeat. The red fringe will repeat somewhere over here maybe. It's going to repeat maybe somewhere over here. So they will start repeating after different times. You will not get a clear-cut pattern because there are many wavelengths and there will be many overlaps and they will be happening at different places. But over here you will definitely get a bright region and there will be a lot of overlaps after this because their wavelengths and their fringes are different. So that's what it's going to get. So with the first order violet fringe being closer to the central violet, no. The first order red fringe being closer to the central, no. So it's going to be a very weird combination. I think it's going to look like this, a central white fringe. Option C, yes, it's going to be a central white fringe and it will look something like this. Look at this, white, reddish, and then there is a random pattern, but it is very colorful because different colors are mixing at different times. Okay, different colors are mixing at different particular times. Okay, very good, my warriors. Wiki, I'll be doing semiconductors towards the end, but if you want the one-shot video for semiconductors, I have already done it last year. Just search for 0 to hero semiconductor Shreyas sir. Very good. Excellent. So Jatin, if you're going to spam, definitely I'm not going to answer. Okay. So in YDSE, only the central maxima is where you are going to get 0th part difference, and that's where all the colors meet and you get white. The reddish extends towards the end because red is big in wavelength, and rest all meet at different points, and you will see a very random colorful pattern out there. That's how it looks like for white colored light. Now let's talk about intensity variation and other things. Very important. And we know that when light waves interfere, and if there is a part difference, there will be also a phase difference, and because there is a phase difference, the intensities need to be added using this formula. The intensity of the resultant wave will be I1 plus I2 plus 2 root I1 I2 cos del phi. Now this del phi is nothing but 2 pi into delta x divided by lambda. Delta x is your path difference. Remember, delta x was nothing but d sine theta, and if you wanted, you can also write d sine theta as dy by capital D. So this is the logic tree which you need to follow. This is the mind map which should be there in your notes. And what is I1 I2? I1 I2 is nothing but the intensity on the screen due to each slit. Due to slit number 1, what is the intensity? Due to slit number 2, what is the intensity? Usually the slits are of the same size. So if they are of the same size, then what will happen? If you have same size slits, then you will have I1 will be equal to I2, and then you can solve this, and you are going to get the resultant intensity will be 4 times of I1, and you will have, or I2, whatever you want to call it, cos square, del phi by 2. This comes via the half angle or the double angle formula. You can easily get that. That's very, very simple. But remember, this is only true when the intensities are same, else you're going to make use of this formula in general. So the intensity on the screen due to the slits depends on the width of the slit. It depends on the width of the slit. If the slit is more wide open, more light will pass, more the intensity. If less light, that means lesser is the width of the slit. That's how this works. Okay, keep these formulas and mind maps in your head, and you will find that when you use this formula 4i into cos squared del phi by 2, you will see that the intensity variation graphs look something like this on the screen. I'll explain this to you. Now don't worry about this formula, it's the exact same mind map. Lot of students remember this formula. There is no need to remember this formula. Just remember that mind map which I just gave you. Okay, Achha, del phi is 2 pi delta x by lambda. Okay, delta x is d sine theta. So if you substitute all of that, you exactly get the same thing. There's nothing great about this. What this graph tells you, see, on the screen, if you are here, you get maxima. Maxima means bright fringe. So the intensity is highest. The intensity will be highest. Correct? Maximum intensity. And that can happen only when this term is 1. Because cos maximum value is 1. Sine's maximum value is also 1. Cos square's maximum value is also 1. So when this becomes 1, you'll get a max value intensity of 4 times of I naught. Then the least value is 0. Cos squares usually the least value is 0, right? Cos square, because it's a square, not minus 1, it will be 0. So the least intensity will be at minima. It will be at minima, and that will be basically your dark fringe. So that's where the intensity will die down. And again it will pick up. Again it will die down. Again it will pick up. Again it will die down. So you rotate that, you will exactly get this. So these are the maximum intensity points. These are your dark points or minimas or dark fringes. Is that now understood? Is that now understood? Rizwana, yes, but when I have to take 2 classes, obviously I have to conduct one class somewhere around 7:15 and the other class at around 5:30. Okay, so there are 2 classes that I'm conducting today. So keep this in mind. Perfect. So let's start solving some questions. In YDSE, the interference pattern is found to have intensity ratio between the bright and the dark fringe as 9:1. Find out the ratio of intensities, amplitude of the 2 interfering waves. Come on, think about it. Come on, warriors, think. And yes, my next class, I think I'll have to shift it a little bit to 7:30. So I'll just mention that. Yep. Okay. So I have messaged the admin. I'm pretty sure they will change it. So my next class will be at 7:30. Okay, which is the sprint class, because I think I'm going to overshoot 7 o'clock. I don't want to cut short of my portion just because I have a class ahead. Okay, I'm not that kind of a guy. So what do we need to do? In a YDSE setup, the interference pattern is found to have intensity ratio bright to dark as 9:1, ratio of intensities and amplitudes. So what is given? Given is the maximum intensity by the minimum intensity is in the ratio of 9:1. When will you get maximum intensity? When you have constructive. And when you have constructive, do you remember the formula that I gave you? The maximum intensity formula is root I1 plus root I2 whole square. I gave this to you during the recap. If you have joined in late, go back. At the start, I have done a recap of the previous parts, and over there I have given you this formula. And if you have not understood that formula, then go back to the previous session, lecture number 2. I derived that exactly over there. Yeah. Now, same thing for minimum intensity. I have told you it is root I1 minus root I2 whole square. So this is for basically constructive interference. This is basically for destructive interference. So this is 9/1. If this is 9/1, take square root on both sides. You will have root I1 plus root I2 divided by root I1 minus root I2. This will be 3/1. Now once you get this, use componendo and dividendo. This is componendo dividendo form. So use that formula and you will see it will become very simple. If you use componendo dividendo, what you will get? You will get root I1 by root I2. If you have forgotten what componendo dividendo is, P by Q. If it is A by B, then P plus Q by P minus Q will be A plus B upon A minus B. So this is your componendo dividendo formula. So this, when you solve it, you are going to get root I1 will add up, root I2 will subtract on the numerator side, and then the denominator side, root I1 is going to subtract. Okay, so this will become 3 plus 1 upon 3 minus 1. And now 3 plus 1 is 4, 4 by 2, that's 2 by 1. Square it again, so you are going to get I1 by I2 will be 2 by 1 whole square, which is basically 4 by 1. So the first answer is 4:1. That's the answer. Now the next question says, what's the amplitudes ratio? What's the ratio of the amplitudes? So A1 by A2 whole square will be I1 by I2, because remember, intensity is directly proportional to the square of the amplitude. Do you guys remember that? Square of the amplitude? Yep. So Hariharan, there is a link in the description box, bacha, which is the pro subscription for 11th or 12th. You can just click that link. You will get all my micro courses for free of cost once you are in the pro subscription. Yep, all my courses. Alright, so there is a link out there for pro subscription. If you are 12th, choose 12th. If you are 11th, choose 11th. Use the coupon code. You will be getting all my courses. Alright, now because of this, take square root on both sides. You will get A1 by A2 will be root I1 by I2. So I1 by I2, that's 4 by 1. So root of 4 by 1, which is nothing but 2 by 1. Hence the next answer is going to be 2:1. That's the answer. Does it make sense? Perfect. All right, let's move on to the next one coming up on your screen. Yep, there we go. Okay, yes, next question. Arnav, these are mains plus advanced, so I cannot take completely difficult questions right when I'm teaching the concepts. So that's why I have dedicated advanced problem solving sessions separate, where there are very high level questions, and then you have mains plus in between advanced questions, just so that you understand the topic, because I want you to understand the topic first, and then only we can scale up to higher level problems. So we have both kind of mixture over here, but yes, exclusive problems in the advanced sessions. So you have a YDSE setup, and the maximum intensity is I0. The distance between the slits is 5 lambda. Wavelength is given. What will be the intensity of light in front of one of the slits on the screen at a distance of, the screen distance is 10D. Wow, what a beautiful question. This is going to be, yes, this is like advanced level question, you can see. Now observe this. See, you have the screen over here. These are the two slits. Okay, this is your central line. This is your point O. This is slit 1. This is slit 2. The question is, what will be the intensity of light in front of one of the slit? In front of one of the slit means directly over here, exactly at this point. So first of all, try to understand, we need to figure out what is the phase difference, and for the phase difference we need to know the path difference, and for the path difference we need to know the angular position. Remember, angular position is always measured from the center. Angular position is always measured from the center. So this is basically your theta. Now if that is your theta, and this is the base of a right angle triangle right over here, and imagine this to be basically D. So how much is this, my warriors? This is basically D by 2. Correct? This is basically D by 2. Now you can figure out what is theta. So what is theta? So tan theta will be equal to theta approximately, because small angles, that will be opposite by adjacent. So opposite is D by 2. Adjacent, this base is nothing but capital D. Okay, so now start substituting all the values. So small d is 5 lambda. So 5 lambda by 2, and capital D is 10 small d. 10 small d. So this 5 and this 10 will cancel. This will become 2. So this will become lambda by 4d, and this d, small d, is nothing but 5 lambda. So this will become, correct? This will become 5 lambda over here. So therefore lambda will cancel. 4 5s are 20. So it will become actually 1 by 20. Okay, now that I know theta, now I'll find out path difference. So delta x, which is d sine theta, which is also d tan theta by approximations which I have told you before, that will become, okay, what is small d? Small d is nothing but 5 lambda. Tan theta is nothing but 1 by 20. So 5 and 20 will cancel. Yes, I'll get this as lambda by 4. So delta x is lambda by 4. From delta x, find out phase difference, because only then you can find out the intensity. So phase difference, this is phase difference. This is not to be confused with this theta. This theta is the actual angle. Phi is the phase difference angle. So this is 2 pi into delta x divided by lambda. So 2 pi by lambda. Delta x is nothing but lambda by 4. So this is going to be pi by 2. Perfecto. So we got the phase difference as pi by 2. Now the only thing remaining is the formula for intensity, which we all know. The I intensity is 4 I0 is there outside. That 4 I0 is basically the maximum intensity into cos square del phi by 2. That is your formula. According to the given question, the max intensity is I0. The max intensity is I0. What is the intensity at some particular point? So at that point, I have just found out the value of del phi. So let's just figure this out. So this will be I0 into cos square. Del phi is pi by 2. So pi by 2 by 2, which is pi by 4, which is 45 degrees. Cos 45 is 1 by root 2. So this will become equal to cos 45, which is 1 by root 2 square, which is I naught divided by 2. Is I naught divided by 2 there somewhere? Yes, it is. That is not option D, it is option A, bacha log. Okay, so that's how you solve the question. So in the question, we were asked what's the intensity given the maximum intensity at some random point. So for that random point, we need to find out what is the phase difference. For the phase difference, we need to find out what is the path difference. So to find out the path difference, we need to know the value of sine theta or tan theta. To find out tan theta, we made use of geometry. The point was located here. If this was D, this is D by 2, and tan theta will be opposite by adjacent. Rest all are substitutions. Everybody got this point? Everybody got till here? Shall we move ahead? Shall we proceed ahead? Okay, beautiful question which came up on your screen. Next is displacement of a fringe because of a glass slab. Okay, let's have a look at this. Okay, I'll tell you how to perceive whenever a glass slab is placed in front of one of the slit. Okay, I'll give a simple logical explanation. Imagine Pandu and Champa have to start from the points over here, and this is your finish line. They have to go somewhere here. Now, if Pandu and Champa are asked to reach this point over here, this point over here, which is equidistant, they will both reach together at the same point. They will arrive at the same point. So path difference, phase difference, everything is 0. Perfect. Now, imagine if they are asked to reach somewhere over here, then Champa has to travel more distance than Pandu. So obviously there will be a lag between them. Now, just imagine this. If you have a rough patch wherever Pandu is walking, okay, there is a rough patch. In that rough patch, Pandu's speed will reduce. Pandu's speed reduces when he encounters those obstacles and that rough patch. You still want both of them to reach together. You still want both of them to reach together. Then, where do you think you should ask them to come or ask them to reach so that they arrive simultaneously? I'll repeat the statement. Because Pandu's speed reduces in this rough patch, so you have to give him that advantage. How are you going to make that arrangement? Where will you ask them to meet? Will you ask them to meet on the top, here, or at the bottom, so that Pandu and Champa arrive simultaneously? Think again. Yes, DMYT kids, we are going to have the sprint session at 7:30. If both of them start from here and Pandu encounters the rough patch, you will see Pandu will lag behind and Champa will reach here first. Correct? So obviously, if you meet at this blue point over here, obviously Pandu will lag behind Champa. If by chance you ask them to meet somewhere over here, then what will happen? At this point over here, let's say this red point, then Pandu not only has to travel long distance, but will also get stuck in this region, because of which what will happen? Obviously Champa will reach first, they are not arriving simultaneously. Now if you go at that green point over here, okay, let's say I call this point green, then because Pandu gets stuck, you ask him to travel less distance. So when Pandu gets stuck, he is traveling with lesser speed. Champa meanwhile moves ahead and then both of them reach simultaneously. So basically what has happened is, if you introduce a glass slab, it's like slowing down that ray. So because you are slowing down that ray, you are asking that ray to go less distance. And then what will happen? You will find a point where both the rays will reach simultaneously in spite of the ray being slowed down, because you are asking it to travel less distance. Hence, because both the rays reach here simultaneously, that's very similar to your central maxima. What was the logic behind central maxima? At central maxima, both the rays reach simultaneously. That's why it was called as the central maxima. Because of the slab, now the rays reach simultaneously, but not at this point, at this point. So what has happened? There is a shift happening over here. So the pattern shifts. The pattern shifts wherever you place the slab. If you place the slab below, the pattern will shift below. Is that making sense? Is that understood, my warriors? Got it? So this is how the shift happens. So the moment you place a glass slab, okay, the pattern shifts. The pattern shifts. Fringe width is still the same, obviously, because wavelength is same, D is same, capital D is same. That is not going to affect. And the idea behind that point or that shift can be found out like this. If I call this as Y shift, at that point, ignoring that glass slab, just ignore that glass slab, there is a part difference. Just ignore the slab, there is a part difference. If that same part difference is introduced by the glass slab, it will be nullified by it. I'll repeat. Ignore the slab, the ray too has to travel more distance. There is some path difference associated. That extra path that ray too has to move. That much path difference, if it is created because of the glass slab, which is going to make it slowed down, that will exactly compensate at that particular point. So that's where you will have the central maxima. So this is where you are going to get your bright fringe. This is your zeroth bright fringe. That's where both of them reach simultaneously. So I'm just going to say that the path difference created because of the rays, if it is equal to the path difference created because of the slab, then the rays will arrive together. That means it will create your zeroth maxima. Zeroth because both are having no difference, maxima because they arrive together to create constructive interference. So what is the path difference by the rays? It is nothing but d sine theta. The path difference because of a slab, do you remember it? It was t into mu minus 1, correct? T into mu minus 1, but sine theta is nothing but tan theta. So this is again t into mu minus 1. So tan theta is nothing but y divided by d. Sine and tan are similar because angle is small, and tan theta will be opposite by adjacent, which is y by d. So this will be into t into mu minus 1. So y shift will be equal to t into capital D into mu minus 1 divided by small d. So that will be your final answer. T capital D into mu minus 1 divided by small d. Perfecto. That's what the answer is. Okay, that's what the answer is. Okay, so this is something which you should remember. If you don't remember this, at least remember this. D sine theta is t into mu minus 1, or d tan theta is to t into mu minus 1. If you remember that, you can easily come to this particular formula. As simple as that. So this is a shift produced by, a glass slab. And you might ask, sir, what if there are two slabs? Well, each slab will produce a different shift. So for example, if you have a slab 1 over here, it will create a shift here. Slab number 2 will create a shift here. So the net shift will be shift 1 minus shift 2. Shift 1 minus shift 2. So if there are two slabs, that's how you calculate the net shift. As easy as that. Okay? Fair enough. Let's solve a question based on this. Hello, Rocky. When a plastic thin film of refractive index 1.45 is placed in the path of the interfering waves, then the central fringe gets displaced by a width of 5 times the fringe width. What is the thickness of the film if the wavelength of the light is 5895 Angstroms? Okay, let's see how many of you can calculate this within a minute. It's very easy. You just need to substitute the values. That's all. Come on, think. First of all, what and all is given? Let's write it down. Mu is known. Okay, wavelength is known. And what else is there? We need to find out the thickness. And it's also given, it shifts by 5 fringe widths. So the y shift value is 5 times of beta, which is 5 times of lambda capital D by small d. And what is the formula for y shift? In case you have forgotten, again remember, simple trick. I've told you, d tan theta d tan theta is t into mu minus 1. If you remember that, that's enough. So d into y by d is equal to t into mu minus 1. So from this you can get the value of y. So the value of y you can see is capital D into t into mu minus 1 divided by small d. Now can you see capital D, small d gets cancelled. So the only thing remaining is small t and that lambda and that mu. So I can solve this. So t will be equal to 5 times of lambda divided by t into mu minus 1. Fair enough? Now just substitute the values. So what is the value of lambda? Lambda is 5895 Armstrongs. So into 10 to the power minus 10. Oh, sorry, I put t by mistake over here. I just had to put mu minus 1. My bad. So mu minus 1. So what is mu? Mu is 1.45 minus 1. So that's 0.45. So this was nothing but 1.45 minus 1, which is 0.45. 0.45 is 45 into 10 to the power minus 2. Fair enough. Now solve this, my warriors. See what will you get? 5 and 45. This will go 9 times. And will 9 go with 5895? Think about it. 9 6 are 54. Okay, just check this out. 6 and yep. Okay. Just check this out. Are you getting 655? Just check this out. This 10 to the power minus 2. This will become 10 to the power minus 8. So it will become 655 into 10 to the power minus 8, which is 6.55 into 10 to the power minus 6, which is 6.55 micrometers. So this is your final answer. Just check this out. Just check this out. Is it 6.55 micrometers? Just check this out. Got it? How to solve this? So it was just about remembering this, how to remember that shift formula, d tan theta is t into mu minus 1. From this you get the shift, and it is clearly mentioned it is 5 times the fringe width. Fringe width is lambda d by d. Just substitute it and you'll get the answer. Okay, rest all are just calculations, as simple as that. Okay, shall we proceed, my warriors? Okay, let's go to the last thing. Now what is the last thing? The last thing is when the slits are perpendicular to the screen. This is a very important case. Slits were earlier parallel to the screen. Now the slits are perpendicular to the screen. So something like this. Something like this. These are the two slits. The screen is over here. Now there is a very interesting thing which happens. See, when your slits, okay, were like this, and the screen was over here, okay, think about it. These were your slits, okay, they were parallel. Then imagine this in 3D. If you reach here like that, you will get a fringe like this. You will get a fringe parallel to the slits. You will get fringes right over here. These are your fringes. The reason why you get these fringes is because if you go in any plane, just try to visualize this. If you go in any plane, let's say you go from here to here, you reach here. You go from this point to this point and you reach here. So if you visualize that in 3D, let me just draw another diagram just to make you understand this. Okay, this is one slit, this is another slit, and let's say you reach at this point, you reach here. You reach at this point, and from here, here. And from this point, you reach here, and then you reach here. If you join all these points, you get a line which is nothing but a fringe. You get a fringe. Try to visualize this in 3D. Try to visualize this in 3D. This is like a plane. This is one plane. Then you have another plane, triangular plane. You can see that. So, you know, all these points have similar geometries. So that's why you get the same pattern or the same interference along this line. So you get a fringe on the screen. Is that understood, my warriors? Is that understood? Look at this. Is that understood why you get an interference pattern on the screen in the form of fringes? Perfect. Is that clear? Now, the moment you make the slits this way, remember the screen is not here. The screen is here. The screen is not here. It's there. Now, all the points which have the same kind of interference, meaning same path difference. All the points which have the same kind of interference or the same kind of path difference will be on, look at this ray will meet here, this ray will meet here. You want the locus, you want the collection of all the points which have the same path difference. Where will it be? Just visualize. If that point is there, if you go around like this, that means you go in a circle. You go in a circle like this. Then all the points will have the same path difference. Can you see that? Can you visualize that? Think about it again. If you're not able to visualize that, let me just draw a circle right over here. Let me just draw a circle. Now whether these two rays meet over there or whether these 2 points meet somewhere else, I don't know, doesn't matter. It's all going to be the same, but they have to meet on this circle. That's it. If they meet on the circle, you will see they will have the same path difference. So you are going to get not fringes, but you are going to get rings. What are you going to get? You are going to get rings, my warriors. So that's what's going to play an important role over here. So when the slits are perpendicular, what you get on the screen is no longer fringes, but you are going to get rings, bright and dark rings. That's what the catch is. And if I ask you, what will you get at the center? Let's see how many of you can answer that. What do you think you are going to get at the center? Are you going to get a bright fringe or are you going to get a dark fringe? What do you think is your answer? Come on, think about it. At exactly the center, are you going to get a bright ring or a dark ring, bright spot, dark spot? What do you think you are going to get? Let's see how many of you can answer this. If you are going to answer this in the first go, that means you guys are really, really smart. Come on, think. Not more than 20-30 seconds. Think, if both the rays meet over here, what do you think you are going to get at that point? Are you going to get a bright spot or are you going to get a dark spot? Think carefully. The logic is very simple. The logic is very simple. See, this is slit 1, this is slit 2, correct? And the screen is somewhere on this line. It's over here. This is the point which I am considering. This ray from slit 1 will travel this much distance. From slit 2 will travel this much distance. Do you see already there is a path difference delta x, which is the distance between the slits? There is a path difference between the 2 rays meeting here, which is the distance between the slits. And how much is this d? Do I know? I am not given. This d, if it is n times lambda, then it will be bright because it will be constructive. But what if it is odd times of lambda by 2? Then it will be dark. And what if it is something else? It will be neither bright, neither dark. That means the answer is it depends on the distance between the 2 slits. So when you have the slits perpendicular to the screen, at this center you do not get central maxima. In fact, here the path difference is basically d, and this interference completely depends on this quantity d over here. You cannot judge it. It depends only when, you can find it out only when you have been given the value. I hope this makes sense. Alright? So very, very important catch, and a lot of people do not know this. We're going to solve more problems, but yes, we are also going to give you homework. So go check this homework out. It's there in the PDF, which will be uploaded in some time. But yes, you can always take a screenshot and put up the answers in the comment section right over here. This is your second homework question. Okay, second homework question, and this is your third homework question. And I'll show you where the previous lecture was. But before that, let me also remind you the crash course for JEE 2022, the term 2 syllabus with term 1 with 11th standard has just started. And if you want to avail that crash course, which has 90 classes along with test series, along with video classes live plus the recordings, along with assignments, now is the best time to join it, because the more you delay, the end date will keep on shifting. And you do not want to shift the end date because you want to be very well prepared for the JEE Main's first attempt. So where are you going to find it? It's very simple. So let me just go behind. All right, just one second over here. And if you're watching this video right now, in the comment section, in the description box, you will see the JEE crash course link right over here. So when you click on this link, you will see the JEE 2022 crash course, which includes the entire syllabus revision, 11th and 12th. And do not choose the light version, choose the classic. Reason is the pricing is the same. I don't want you to choose this because I want you to choose this. You are going to get doubt solving on the mobile app. And when you click on this link, you get the screen where you have to enter your login details. You can register obviously, and you can pay the amount. Also, you are getting that 10% off because the usual course price was 20,000, discount for 10,000, more discount of 10% using my coupon code. That's why you get the course for 9,000 rupees. It's a limited period offer. Seats get filled. Then you are automatically pushed to the next batch. So I don't want you to do that. I want you to get enrolled into the current batch itself. That's one thing. And remember, you are going to get assignments, test series, everything. It's one thing where you get everything, and these crash courses do not end in 1 month. They continue till the last exam, whenever it is, even if it gets postponed. So that's how it is. Okay, so till the last exam, no matter when it is. And those of you are wondering where the previous class was, well, if you go back over here, if you just go to videos, probably just scroll down a little bit, and probably you're going to get it down somewhere over here. I think maybe, I don't know, yes, somewhere here, I guess. Where did I go? Okay, yep, I think, yes, it's somewhere here, okay. Lightwaves and all of that. Yes, right over here, lecture 1. I think there is lecture 2 also. Okay, but anyways, just check this out. This is that lecture where, you should start watching it from. I'll just pin the comment, or maybe I will just put the playlist for the Lightwaves so that you can find all the things properly. Okay, so this is where you post all your comments and post all your answers. Thank you so much, everyone. Let me also like all your lovely comments, and because you have also solved the questions and posted the homework answers itself over here. Thank you, everyone. And make sure you post the answers for today's session as well in the comment section. Okay, so thank you very much. Thank you for liking. Thank you for enjoying. Thank you for staying. See you in some time for the sprint session. Okay, bye bye. This was Shreyas here, signing off. Hasta la vista.